Assalamualaikum warahmatullahi wabarakatuh. We would like to present our project term in computer network design, COE-546. Our project is a VRF-Aware fast reroute under failure. This is our team, Netwalker team, Muhammad Hamdani, Abdul Rahman, Rabiu, and Abdul Samad. Okay, the aims of this project is actually to evaluate how four VRF-aware network designs maintain service continuity under link failure and recovery conditions by comparing jitter, packet loss, and throughputs. So the objective is we measure the link condition during the normal condition, and we measure the the jitter packet loss during the failure. So we would like to make simulate the link failures i- during the measurement, and also uh, we measure how quickly traffic stabilize after the routing or link restorations. The tools that we are using is iPerf3 and MTR. This is our first design. The first design is actually all there are three of the routers or the layer 3 switches which represent as the ISP, and it's connected by using the OSPF, and between all the OSPF is the same area, which is the area 0, and along with those networks we have two VRF. In this case we are using the VRF ID, VRF ID blue, and also VRF ID red. So even though they are using the same physical device and same resource for the physical one, we can separate the the network by using different VRF. So between the VRF red and VRF blue cannot communicate directly, and it should be cannot be conflicting. So in this case, let's say we have one of customer which represent in VRF blue, uh, can communicate between the other their branch in different locations. Let's say from Linux one, this is one of the customer, and their branch is located on the connected to the NX3 device, and it can be communicated. And the measurement is we try to disconnect the links by using the shutdown the interface between the NX2 and the NX3. And during the measurement, we measure by using the iPerf3, by using flooding the traffic to measure the bit rates and also the packet loss. And also we also measure by using the MTR, and we can see how much the packet loss is, and also how much the jitter between these two networks. We also measure that the VRF red cannot communicate to VRF blue. So even though they are using same resource, it cannot conflicting. Okay, we go to the next design. The next design is actually more scalable. Even though we just see same what is it same design by three of the routers of the switches only, but in design is different because there are multi-layers network protocol. OSPF is on the underlay, and MPLS on the transport layers, and MPBGP or multi-path BGP VPN is for exchange the VRF. So uh, in case the Linux want to communicate to the Linux 2, it will be used different the VRF, which where the VRF is exchanged by using the BGP, the MPBGP VPN, and it's different from the previous one uh, because in previous one, if we deploy the design P0 in the huge network, it will be we have to configure all the VRF configuration and all the networks devices, let's say on the routers or the switches. But in this case, by using the design P1, we have not we don't have to configure all VRF on all the routers or the switches. And the transport layers using the MPLS, so we are using the level switching. In this case, we are using the LDP, and it differs from the design. The design too, we are using the SR MPLS. It's basically same as the MPLS technologies, but different uh, methodology. In the segment router MPLS, all the nodes from the networks have the kind of router ID like on the EIGRP or the BGP, but in this case it's on the MPLS side. So uh, they can the label the label exchange of the MPLS connectivity by using the segment routing, and it has the TILFA. TILFA is the topology independent loop free alternate, and this is the fast reroute mechanism used by segment routing. Usually, during the link fails or when the link fails, normal routing protocols need a time to reconfigure because there is a kind of routing recalculations, how to reroute the traffic. But by using the TILFA, it can improve by preparing the backup path before the failure happens. This is the best one. So the convergence time is faster. And of course, in this design also the Linux 1 and Linux 2 by using the different VRF, which is uh, the, the exchange is using the BGP. We go to the next design P3. It's actually using the VXLAN, uh, the OSPF underlay, BGP, EVPN, and we use the VXLAN. The VXLAN is like VLAN, but in more global graphical. Uh, so instead of just like normal VLAN by only on the same locations, but we can span the same subnetworks in different geographical locations. So in this case, 192.168.10/0 dot 0/24, it can separate in uh, two locations, and virtually they are like looks like same switching. So the result of the measurement is the performance comparison shows that each network designs can maintain connectivity, but segment routing MPLS with the TI LFA provides the most stable performance during failures and recovery, with lower packet loss, lower jitter, and faster traffic restorations compared to the other design. And here, this is our deployment for the design P0 in IFNG emulator and the design P1 and design P2 and also design P3. So this is our deployment on the IFNG emulator or simulator, and we measure between the Linux to measure by using the iPerf and also uh, the MTR. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.